Welcome, dear students. I am Rajiv Lohni and I am here to continue the topic dimensional analysis in this video. Today, we will see the applications of dimensional analysis. Before this, I would like to discuss a very important term related to dimensional analysis that is called the dimensional homogeneity. Dimensional homogeneity is a term which actually has been referred to you in my previous discussions. You know that any physical equation will have at least two terms, or it will have more than two terms. Whatever be the number of terms, you will find that every term in a given equation has the same dimensions. If there are two terms which have different dimensions, then the equation cannot be correct. As I have referred to you in the previous video, that only similar dimensions can add. So, in order that an equation is correct, the basic need is that there should be dimensional homogeneity. I will give you a very simple example. We have an equation S equal to ut plus half at square for a uniformly accelerated particle, where s is the distance traveled in time t, a is the acceleration, and u is the initial speed of that particle. Now you will see that in this equation all these three terms have the same dimensions. First, see the left hand side term. S is distance, so its dimensions are L. Then come to the first term on the right side. Its dimensions are dimensions of u multiplied by dimensions of t, that is dimensions of speed into dimensions of time, which will be Lt minus 1 multiplied by t. This is L t minus 1 plus 1, which is equal to L only. So this term has the dimensions as that of the left side term. Now come to half at square. I told you in the previous video that half is a number and so it will have no dimensions. Now come the dimensions of A. A is acceleration and its dimensions are Lt to the power minus 2. And the dimensions of t square, when multiplied by this becomes Lt to the power minus 2 into t square. T minus 2 and t square cancel and we are left with L only. So you see, in this equation there is dimensional homogeneity. So the first application of the dimensional analysis is to see whether a given equation is dimensionally correct or not. If the equation is dimensionally correct, then only there is a possibility that the equation is correct in real sense. So basic thing is to find out whether a given equation is dimensionally correct. As in this case, we can see that all the terms in the equation have the same dimensions. So we will say that this equation is dimensionally correct. But there is a limitation to this application. Even if we did not have half here, suppose I would write it as s equal to ut plus at square, then too this equation would stand correct dimensionally. But we know that this is actually not correct. So this is a limitation of dimensional analysis. Anyway, the first application has been told to you you can watch the videos for the next applications. Thank you.